Hello everyone, I'm Lakshmi Prasad Chowdhury from Bennett University. Today I'm going to explain you my home assignment. It is about learning a different algorithms to differentiate between the Airbus and Boeing. You know what is Airbus and Boeing? These two are manufacturing companies, and they produce flights. Exactly what I mean. So there is slightly different in Airbus manufacturing designing model and the Boeing designing model. So my motto is with this algorithm, with this machine learning algorithm, I'll differentiate between the Airbus and Boeing. So there are mainly two main factors to differentiate between Airbus and Boeing. The Boeing has a tip noise compared to the Airbus, and Boeing more air wing has a slightly different to the compared to the Airbus. So the wing design and the tip of nose of a Boeing design is slightly different. So compared to the Airbus. So with these two main factors, I'll run the code and I'll test the code and I'll get the good accuracy. So when I put a new image, so my algorithm will tell us that this is a Boeing or this is a Airbus. So coming to the my blog, I have created a blog on my assignment. This the title is classification of flights, Airbus and Boeing using different algorithms. I'm using these algorithms. You can use any one of it. And the first thing I've used is CART, logistic regression, random forest decision tree under SVM and KNN. And this is a picture you all know. And the models involved. The first thing is you have to visualize your data and you have to know the correlation among the features in the image. Like I've told you, I have found that the futures correlation is like there is slightly difference in wing and slightly different tip of a nose in aircraft between Airbus and Boeing. So you have to split the data in training and testing. This is the routine, and I'm using the classification model rather than regression. It's easy to use, and for errorness, I'm using mean square error and precision recall, and at last I'm concluding the best model. So coming to the data, I've taken the data from the Google search and I've taken different type of flight models of and Airbus and Boeing, and I'm using these type of methods. First one is perceptron, decision tree, logistic regression, neural networks, and random forest. So I've done this assignment in Microsoft Azure Notebook. It's a great platform to do machine learning assignments in that. And the first thing, when you're dealing with the image data set, I've told you my data is on image data set. I have downloaded from Google and I've taken few images of Airbus and few images of Boeing, and I've kept them in a different files. And then, so this is I've kept them in different files. This is my data. So when you're handling with the image data, you have to install OpenCV Python. And this is the first I install my pip install OpenCV Python, and you have to import CV2. So this, and you have to import NumPy also. So after importing your necessary libraries, and you have to load the data and pre-processing your data. So when you pre-processing the image data, you can use the different ways, but I have used the simplest way that I have taken the Airbus images, all the all the images I've send it into an array, and this array, this those in that array, the images are converted into grayscale. So I have appended all the Airbus images into an array list of L1 array. So this is my first one. Similarly, I've done for Boeing. The Boeing images, I've before I told you, I've created a file for Boeing, and that file, I've all the photos I've sent it into the list to array. So this is what I've done. This is I just appended to the array all the both Airbus and Boeing image data set. So I've got now two data sets. So coming to whether I've done the correct or wrong, then I'll display my list one third data set under index. So this is my code. This is my code, and so list one third data set. This is my image, and it's came as output like grayscale image, and so it's good, pretty good. I've displayed my images, and when coming to the convolution layers, this why I've done this convolution layers, because I have to measure the tip of a nose of a aircraft. So you have to be clearly, precisely measure the calculation of in a graph. So I have taken the different 4 filters for each image. So this is my code, and the output will be this one. So guys, and this, like, there will be 4 filters here. So the image will be displayed here. This is my 4 filters. This is a grayscale image. So the image is converted into 4 filters. So that's how I've done this. And I've done one more to satisfy myself. This I've converted the image into 3-cross array of edge detection. This implies that this converts the image into the gray image, and like totally gray image. See, it's only measures the tip of the nose. Like, I'll measure this in graph, it measures its own itself, and I'll measure the all the calculations of this. Uh, so I'll display the image of, even for Boeing, right? Boeing. So this is a display of your Boeing image. So after you're inserting the both Airbus and Boeing images into a list, now I'm doing the resizing the data, like resizing the shape of the image to 2500. So everything is good till here. So the main task is, now we have to differentiate between two. We have done the pre-processing in a good way, in an easy way, and we have to we have created 2 arrays, one for Boeing and one for Airbus. So these 2 arrays are converted into one big array. So I've say there are 20 images, like the 10 are like Boeing and 10 are like Airbus. The first 10 like inserted into one array, and other 10 are inserted into one array. So this is the thing, and I have initialized like first 10 images are 1, and next 10 images are 0. So I've initialized that, like, I've inserted first 10 are Boeing and second 10 are Airbus. So first 10 are like, I've inserted like initialized like 1, and this is 0. I've split the data set and training set. I've given the test size because uh, my data is uh, my data is less, and if my data is more, I'll give the test size small, because I'll give the more priority to more training set. So based on your data set, you have to decide what will be your test size. And coming to perceptron, this is a perceptron code. You have to import from sklearn, import perceptron. So ETS should be 0.1 and train your perceptron, and you have to predict the accuracy score between y test and y predict. Y predict is known like x test. So you have to be so this is one method. I've told you I'll tell you like different methods. Like I've told you before, I've tell you different methods. Like one is perceptron, one is decision tree, one is add a boost, and one is random forest. So one is perceptron code and another is decision tree. Similarly, you have to import the decision libraries from sklearn datasets, import load items. This is an important part. And similarly, for every accuracy, you have to do between X test, Y predict, and Y test. Okay. So the main important is I've done F1 score. The F1 score tells me that similarity between them. So I'm doing the main motto is I have to differentiate between them. So I have to get the less accuracy, less similarity. So F1 scores tell me that your similarity between two images is this much. Like it's given between 0 to 1. So my similarity, I will tell you, and my similarity is my similarity is 0.3, then less compared to it. It's not 50% above. It's 0.3 images, because both are in same image, both are flights, and there is only two changes. Like one is tip of nose, and another is design of wing. So it's nothing good as much. Like I got a good similarity, so you can carry on with it. And another method is logistic regression. You guys use any of these methods to get the accuracy. I have showed you different. One is perceptron, one is decision tree, and one is logistic and logistic. So coming to the logistic. So same, you have to import the logistic regression from sklearn. So you have to measure the score extension wise. You will get the score here. The neural network part. So main important. Why do you use neural network to get the to train your data more precise way, to get the less errors, and you do back propagation also to get the less errors. So neural network is a hot topic in machine learning and everywhere, and everyone should learn. Like, it's a good topic, and I know a little bit about neural network because my home assignment should have done in this method. So I've learned about this thing. So I'll show you the right. I'll show you the neural network with the output. I'll go down. So, see, this is my neural network code I've shown in the blog, and you have trained to near 50 epochs. Then see, here my loss is 10, 10, 10, 10, 10, 10, 10, 10, and it's constant. So my accuracy is 0.33. My similarity is 0.33. It's pretty good when you comparing with flight, when you're doing with a flight image data set. So at last, I got accuracy 75. So you can use with the less data also, you can get the good accuracy. There is no use, but you have to get the images more precise way that everyone should, that model should understand in precise way, and you have to train the data in a more efficient way. That's it, and these my neural networks, and moreover, I forgot there's a random forest. It's random forest is a classification algorithm, and this tells an uncorrelated forest of trees and individual trees. And this is from sklearn.assemble import random forest classifiers, and we'll get the accuracy. And the overall summary is like you will get the accuracy. Like I got the accuracy in neural net. I'll show you in the output neural net is 75%. I got it 75%. That's pretty good, and my accuracy is 75% in neural networks. And so when I put a new image and the input, so I can definitely say that this is Boeing or this is a Airbus. So you can, anyone, my viewers, and you can use this any one of algorithm to predict the or to distinguish between Airbus and Boeing. This is all my summary. Thank you for watching this video.